Let us learn about the program counter and data pointer. Both of them are 16-bit registers. Each is used to hold the address of a byte in memory. Program counter contains the address of the next instruction to be executed. It doesn't hold any internal address. Whereas the data pointer, or in short we call it as DPTR, it is a 16-bit register which can be used as two 8-bit registers, namely DPH and DPL. It holds the address of internal as well as external code and data that can be accessed. It does not have a single internal address. DPH and DPL are assigned with respective addresses. There are totally 34 general purpose registers, or we call them as the working registers, out of which two of them are the accumulator or the A register and the B register, which is used to hold results of many instructions, particularly the mathematical and logical operations performed in 8051. The remaining 32 registers are divided into four register banks, where each register bank holds 8 registers. Accumulator is used for addition, subtraction, multiplication, division, boolean and bit manipulation, and also for data transfers, whereas B register is used for multiplication and division operations. It can also be used for data to be stored temporarily. Next is the program status word register. Flags are 1-bit registers which are used for storing the results of certain program instructions. Other instructions can also test the condition of the flags and then make certain decisions based on them. Flags are grouped inside a single register called as program status word register, and also in power control register. 8051 has four mathematic flags which respond to mathematical operations, and there are three general purpose flags that can be cleared or set by the programmer whenever required. The mathematical flags are carry flag, auxiliary carry flag, overflow flag, and the parity flag, whereas the user flags are F0, GF0, and GF1. PSW contains math flags, F0, and the register select bits that identify which of the four general purpose register banks is currently used by the program. The remaining two general purpose flags, that is GF0 and GF1, are stored in the power control register. The program status word register format is shown over here. You have the carry flag, auxiliary carry flag, general purpose flag F0, register bank select bits RS1 and RS0, overflow flag, this bit is reserved, and then you have the parity flag. The details of every bit is being shown over here, which you can go through it. Let us learn about the special function registers now. 8051 operations do not use the internal 128-byte RAM address from 00H to 7FH. They are grouped as specific internal registers called as the specific special function registers, which may be accessed or addressed like your internal RAM using the addresses from 80H to FFH. These SFRs allows the programmer to change only what needs to be altered, leaving the remaining bits in that SFR unchanged. They are named in certain opcodes by their names like A, TH0, or sometimes referenced by the opcodes by their addresses like 0EH or 8CH. Any address used in the program must start with a number. Thus, address E0H for the A SFR begins with 0. If 0 is not inserted, then the assembler will give an error. Now the slide shows different SFRs with their bit address as well as byte addresses. This is a slide which shows different SFRs with their internal RAM address. Say for example, interrupt enable register is 0A8H, port 3 is 0B0H. Similarly, power control register is 87H, timer mode register is 89H, and so on.